Right now, in the middle of the Pacific Ocean, the water is heating up faster than it has in 45 years of recorded data. Faster than 1997, faster than 2015. Those 2 years gave us the strongest El Niños ever measured. This one is on pace to beat both of them. And if that happens, it will not just change your weather app for a few weeks. It will change your winter, your grocery prices, your monsoon next year, and in some places, it could bring floods, droughts, and heat waves at the same time, just in different corners of the planet. Before I show you the numbers, hit that subscribe button and turn on notifications, because I track this event every single month, and you do not want to miss what happens next. Now let's get into the data. Let's start with what scientists are actually watching. There is a patch of ocean in the middle of the Pacific called the Niño 3, 4 region. It sits along the equator, roughly between 170 degrees west and 120 degrees west longitude. Scientists watch the surface temperature of this one patch of ocean because it is the single best early warning signal for how the entire planet's weather is about to shift for the next 6 to 12 months. When that patch of ocean gets warmer than normal for a sustained period, we call it El Niño. When it gets colder than normal, we call it La Niña. And when the warming crosses 2 degrees Celsius above the long-term average, informally, media and forecasters start calling it a Super El Niño. NOAA does not officially use that term, but this is exactly the threshold this year's event is projected to cross, and cross by a wide margin. Here is where it gets serious. On July 16th, the United States Climate Prediction Center, which is part of NOAA, put out an updated outlook. Just 4 weeks earlier, in June, that same outlook gave a 60% chance that this El Niño would become very strong by the October to December window. By mid-July, that number had jumped to 81%. That is a massive jump in confidence in just 1 month. And it was not a small revision either. In that same July update, the measured sea surface temperature anomaly in the Niño 3. 4 region had climbed to 1.3 degrees Celsius above normal, up from 0.9 degrees just 4 weeks before that. The models behind this forecast are now projecting a peak of around 2.5 degrees Celsius above average, and that is up from a projection of 1.9 degrees just 1 month earlier. Every single update this year has moved in the same direction. Stronger, faster, sooner than expected. Now, some of you might be thinking, okay, 2.5 degrees, is that actually a big deal? Let me put it in context using the 2 strongest El Niños ever recorded, so you can see exactly where this one stands. The 2015 to 2016 El Niño peaked at 2.57 degrees Celsius above average in November 2015. That is currently considered the strongest El Niño ever measured using the most common index. The 1997 to 1998 El Niño peaked at 2.42 degrees Celsius in November 1997 and again in January 1998. That event is the one most people over the age of 30 still remember because it caused floods, landslides, and wildfires across multiple continents. Before that, the 1982 to 1983 El Niño peaked at around 2.43 degrees Celsius. As of early July 2026, NOAA's own model guidance was showing something like a 60 to 63% chance that this event ranks among the largest El Niño events in the historical record going back to 1950. That number has since moved up to the 81% figure I mentioned earlier, but it shows you that even the most cautious government agency tracking this event was already treating a historic El Niño as the most likely outcome months ago, not a fringe possibility. Newsweek, citing NOAA and GFDL model output, reported that current projections show sea surface anomalies potentially reaching 3 to 4 degrees Celsius above average in parts of the equatorial Pacific, which would place this event among the strongest ever observed since modern satellite and buoy records began. So why is this El Niño moving faster than the 2 record holders from 1997 and 2015? This is the part most headlines skip, and it is actually the most interesting piece of the story. Climate scientist Zeke Hosfather compared the daily sea surface temperature anomaly for every year since 1982, lining each year up by calendar date so you can compare apples to apples. What he found is that no prior year in that 45-year record has been anywhere near this warm at this point in the calendar. Not 1997, which was sitting at 1.6 degrees Celsius above average on the equivalent date. It has to do with what is happening underneath it. In late May 2026, instruments recorded a subsurface temperature anomaly of about 8 degrees Celsius above average, sitting roughly 100 to 150 meters below the ocean surface, moving eastward along the equator. This is warmer, at that same stage of development, than the equivalent subsurface measurements taken during both the 1997 to 1998 and the 2015 to 2016 events. Why does this matter? Because that pool of warm water below the surface is essentially the fuel tank for the El Niño above it. As trade winds weaken, that stored subsurface heat gets pulled up toward the surface, sustaining and intensifying the warming through autumn and into winter. A bigger fuel tank generally means a longer, stronger event. This is one of the key reasons scientists are not dismissing the record-breaking projections as hype. The ocean's plumbing, several layers down, is already primed for a big event. On top of that, meteorologist Ben Knoll pointed out that sea surface temperatures in the Niño 3 region had been sitting at record high levels for over a month straight, as of late July 2026, closing in on the 40-day streak record that was set during the historic 1997 event. When you have a persistent, unbroken streak of record warmth like that, it tells you the warming is not a short-lived spike. It is a sustained structural shift in the ocean, which is exactly the kind of signal that precedes a major El Niño winter. Now, here's something that matters if you actually want to understand these forecasts, and it is a detail most videos on this topic will not tell you because it is a little more technical, but I think it makes you smarter than 90% of people talking about this online. Not every source agrees on exactly which El Niño was the strongest, and the reason is not sloppy science. It is a genuine methodology difference. NOAA's Climate Prediction Center has traditionally used something called the ONI, the Oceanic Niño Index, which is just the raw 3-month running average of the sea surface temperature anomaly in the Niño 3 region. On that index, the 2015 to 2016 event is the strongest on record, narrowly ahead of 1997 to 1998, at around 2.6 degrees Celsius, but there is a newer index called the RONI, which became NOAA's official standard as of February 2026. The RONI subtracts out the broader tropical-wide warming trend before calculating the anomaly, essentially separating the El Niño signal from decades of background global warming. On the RONI, the 2015 to 2016 peak drops slightly to around 2.4 degrees Celsius, and under that adjusted measurement, some analysis actually puts the 1982 to 1983 event ahead of it. This is not a small rounding difference. It is the reason you will see slightly different rankings depending on which article you read, and it is also a preview of a conversation we are going to have more of in the coming months, because as this 2026 to 2027 event peaks, you are going to see debates about whether it is record-breaking depend heavily on which index gets used to measure it. Let's talk about when this thing is actually expected to peak, because that is the number most of you actually care about for planning purposes. According to NOAA and GFDL model forecasts reported by Newsweek, the event is expected to peak somewhere between November 2026 and January 2027, before gradually weakening through the rest of winter and into spring. The World Meteorological Organization has said the most rapid strengthening was expected to happen between July and September 2026, with impacts expanding globally through the Northern Hemisphere autumn. So if you are watching this any time before winter fully sets in, you are watching this event on the way up, not on the way down. The real test of how strong it becomes will show up in the data between November and January. Now let's get into what this actually means for your winter, because that is the part everyone actually cares about. I am going to walk through this region by region, using what typically happens in El Niño winters, combined with the specific signals forecasters are already seeing for this particular event. In North America, the classic El Niño winter pattern looks like this. Much of the north-central United States, along with large parts of Canada and Alaska, tends to run warmer than normal, with less snowfall than usual. This happens because El Niño tends to lock the coldest Arctic air up on the other side of the hemisphere, instead of letting it spill down into the middle of the continent, the way it often does during La Niña winters. At the same time, the Pacific jet stream tends to become longer and more active, stretching further east and pulling more storm systems into California and across the southern United States. That typically means a wetter winter for the American South and for California specifically, while the northern tier of the country tends to stay drier and milder than average. But here is the twist, and this is genuinely the part that even some experienced forecasters did not expect a few months ago. Now let's talk about the part of the world that actually depends on rainfall for survival, not just for a mild or wild winter. This event does not just affect winter weather. It reaches backward into the monsoon season that just wrapped up, and it reaches forward into how food and water security look over the next year. According to Pakistan's Meteorological Department, following a formal regional forum held in Malé involving meteorological services from 9 South Asian countries, the consensus going into the 2026 southwest monsoon season, which runs from June through September, was that most of South Asia would likely see below normal rainfall, especially across the central parts of the region. Some pockets in the northwest, the northeast, and parts of the south were expected to see normal to above normal rainfall, but the broader picture for the region's agricultural heartland was drier and hotter than average. The same forum noted that minimum and maximum temperatures were expected to run above normal across most of South Asia during this period. This lines up exactly with the historical pattern. El Niño tends to weaken the South Asian monsoon by disrupting the atmospheric circulation that normally pulls moist air up from the Indian Ocean into the subcontinent. For Pakistan specifically, this pattern has real consequences. El Niño years are historically associated with weaker monsoon rainfall, warmer winters, and an increased frequency of heat waves during spring and summer. This stands in sharp contrast to La Niña years, which are strongly correlated with above normal monsoon rainfall, and in some cases, dangerously above normal rainfall. It is worth remembering that 2 of Pakistan's most severe flood events in recent memory, the floods of 2010 and the catastrophic floods of 2022, both occurred during La Niña conditions, not El Niño. That does not mean an El Niño year is automatically a safe year. A season that looks drier overall on average can still produce sudden flash floods because the erratic, unpredictable nature of a shifting monsoon can bring intense bursts of rain in short windows, even inside an overall below normal season. For farmers and water planners, the real challenge in an El Niño year is often not simply less total rain, but rain that becomes harder to predict, arriving in the wrong week or missing the right week entirely, which can jeopardize entire harvests even when the seasonal total looks roughly normal on paper. It is also worth zooming out to the bigger global picture here, because El Niño years do not just reshape regional weather, they tend to reshape the entire planet's average temperature for that year and the following year. El Niño events release a large amount of extra heat from the ocean into the atmosphere, which is part of why previous El Niño events have coincided with major global temperature records. The El Niño of 2023 and 2024 helped push 2023 into becoming the second hottest year ever recorded at that time, and then helped push 2024 into becoming the hottest year ever documented, a record that stood until it was broken again. Given that this developing event is on pace to be stronger than either of those, and potentially stronger than any El Niño ever measured, it is reasonable to expect that 2026 and 2027 will be closely watched for similar global temperature records, on top of whatever regional weather extremes show up along the way. I also want to walk you through what happened during the last 3 events that reached this very strong threshold, because history genuinely is one of the best tools we have for understanding what might come next, even though every event is unique. The 1982 to 1983 El Niño is historically significant not just because of how strong it was, but because of how completely it caught everyone off guard. The ocean observing network that gives modern forecasters months of advance warning today simply did not exist yet in 1982. The event developed and intensified rapidly, catching both scientists and governments unprepared. It produced serious drought conditions in Australia, major flooding in Peru and Ecuador, and widespread agricultural disruption, with damage estimates ranging from $4 to $8 billion. That event was actually the reason the modern ocean buoy monitoring system, known as the TAO and Triton Array, was built in the first place. In a strange way, the surprise of 1982 is the entire reason we now have the early warning system that let scientists spot this 2026 event coming months in advance. The 1997 to 1998 El Niño remains the most damaging event of the 20th century by most measures. It is estimated to have contributed to around 23,000 deaths worldwide, and roughly $35 billion in damage, according to figures compiled by NOAA's National Centers for Environmental Information. That event produced devastating floods, landslides, and wildfires across multiple continents, and it is the event that turned the term El Niño into a household phrase that most adults still recognize today. The 2015 to 2016 El Niño is, by the most commonly cited index, the strongest event ever measured, peaking at around 2.57 degrees Celsius above average in November 2015. It triggered a global coral bleaching catastrophe, damaging reef systems around the world. And it is also remembered for a famous forecasting miss, where predictions of a historically wet winter for Southern California largely failed to materialize in the way many expected. That particular event is part of the reason forecasters today talk more carefully about probabilities and ranges, instead of making single confident predictions, because even a record-strength El Niño does not guarantee that every single regional forecast plays out exactly as the textbook pattern suggests. There's also a global commodity and food story hiding inside this event, and if you follow markets at all, This is the part that actually affects prices at your local shop, not just the weather outside your window. El Niño years have historically pushed up prices for a specific group of crops that depend heavily on stable rainfall in very specific regions. Indonesia and Malaysia produce the majority of the world's palm oil, and El Niño typically brings drier conditions to Southeast Asia, which can reduce palm oil yields and push global cooking oil prices higher. Coffee is another classic example. Vietnam is the world's largest producer of Robusta coffee beans, and Brazil is the largest producer of Arabica beans. And El Niño tends to bring drought risk to Southeast Asia, while sometimes bringing excess rain at the wrong time to parts of Brazil, a combination that has historically squeezed global coffee supply and raised prices. Cocoa follows a similar pattern, with West African growing regions sensitive to the rainfall shifts that come with a strong event. None of this means prices are guaranteed to spike this specific year, because supply chains depend on many other factors too. But it explains why commodity traders and agricultural economists watch Niño 3. 4. Sea surface temperatures, just as closely as meteorologists do. Australia and Indonesia sit on the other side of the Pacific from where all this warm water is pooling, and that geography matters a lot. When the warm water shifts toward the central and eastern Pacific during El Niño, it pulls the normal rising air and rainfall away from the western Pacific, which includes Indonesia and northern and eastern Australia. This typically means a drier season for Indonesia, with elevated risk of the kind of dry conditions that fuel large-scale land and forest fires, and it typically means below-average rainfall for large parts of Australia, which raises bushfire risk heading into the Australian summer, since their fire season lines up with the Northern Hemisphere's winter months. Australia's Bureau of Meteorology tracks this same Niño 3, 4 index for exactly this reason, because a strong El Niño is one of the clearest known predictors of an elevated bushfire risk season for the country. On the other side of South America, the pattern typically flips. Along the coast of Peru and Ecuador, El Niño is actually named for this exact region because Peruvian fishermen centuries ago noticed the warm current arriving around Christmas time, which is where the name El Niño, referring to the Christ child, originally came from. When the warm water arrives off the coast of Peru, it disrupts the cold, nutrient-rich current that normally supports one of the largest fishing industries in the world, particularly the anchovy fishery, which is a major global source of fish meal used in animal feed worldwide. Strong El Niño events have historically caused significant disruption to Peru's anchovy catch, while at the same time bringing a heightened risk of flooding to the normally arid coastal regions of northern Peru and southern Ecuador, since the warm ocean water fuels unusually heavy rainfall on shore. So in the same event, you can have serious flooding risk in coastal Peru at the same time as serious drought and fire risk in Indonesia and Australia, which is exactly why calling El Niño simply good or bad misses the point. It is a redistribution of the planet's rainfall, taking moisture away from some regions and dumping extra moisture onto others, all driven by the same shift in Pacific Ocean temperatures. That last point is actually the most important thing I want you to take away from this entire video. A Super El Niño is not a guarantee of any single outcome in your specific city or country. It is a shift in the odds, a fundamental change in the background conditions that the atmosphere is operating under for the next several months. It loads the dice towards certain outcomes: warmer winters in some places, wetter winters in others, weaker monsoons, more active Pacific storm seasons, quieter Atlantic hurricane seasons, and, as we just discussed, it can even load the dice towards sudden polar vortex disruptions that produce short bursts of extreme cold in places that are otherwise trending warm. But loaded dice can still land in unexpected ways, and 2015 to 2016 is proof of that. So here is where things stand as of right now. NOAA's Climate Prediction Center has this event at an 81% chance of becoming a very strong El Niño for the October through December window, up sharply from 60% just 1 month earlier. Sea surface temperatures in the Niño 3. 4 region have been climbing consistently for months, sitting at 1.3 degrees Celsius above average in mid-July and continuing to rise. The subsurface heat content, the fuel supply for this whole event, was already warmer at this stage than either of the 2 previous record-holding events. Multi-model consensus forecasts now put the potential peak somewhere around 3.6 degrees Celsius above average, which would make this the strongest El Niño ever recorded if it plays out the way current models suggest. The event is expected to peak between November 2026 and January 2027, meaning the next few months are exactly when we will find out how this story actually ends. If you found this breakdown useful, this is exactly the kind of tracking I do every single month on this channel, following the real data from NOAA, the World Meteorological Organization, and independent climate scientists, and translating it into plain language you can actually use. Subscribe now so you do not miss the next update, because this event is still developing, And the next few months are going to tell us whether 2026 to 2027 becomes the strongest El Niño ever recorded, or whether, like 2015, it still has a few surprises left in it that nobody is expecting yet. Drop a comment and let me know which part of the world you are watching this from, because I want to cover the regional impact that matters most to you in the next video. Thanks for watching, and I will see you in the next one.